The need of raw materials. Raw materials are necessary for most things in our daily lives, from our clothes that we cannot produce without machinery containing electronics and raw materials from a wide range of metals. Steel, for example, that is used in many applications around us, is composed not only of iron but also of alloy metals like vanadium. Buildings, like what we see here on the right, they're comprised not only of cement and wood, but also sand and gravel, as well as copper in electric wires and water pipes. Reinforced by iron and steel. Without that, they would not be able to stand, actually. It would be too brittle. And it would be not possible to build any larger buildings in earthquake-prone areas, for example. The windows, they consist largely of quartz. Trains, cars, boats, and airplanes consist of a vast amount of raw materials. Mobile phones and computers, like what I have here, my cellular phone here. It is up to 60 different raw materials, mostly metal and silicon, which is derived from quartz, which is derived from sand. Batteries, electric vehicles, and solar panels, turbines for wind, water power, and nuclear power all need metals and raw materials. All metals, sand, gravel, are raw materials that are extracted from the earth. So, what is the situation that we are facing in today's EU? We are extremely dependent upon import of minerals. This has not always been the case. So in the 19th century, Europe stood for a lion's share of the production of value of metals and minerals. Today, it's only 3 to 4%, and we are actually consuming quite a lot more. Then secondary raw materials. Can use of recycled raw materials remove the need for mining for metals? They can be recycled in iron ore smelter to the right, as well as it can produce iron from primary ore. There are several aspects. Large efforts are put in within the EU to recycle raw materials from spent products. But many raw materials are yet not recycled in high enough proportions. Reasons can be technical difficulties, that it's the mix of raw materials that come from the products makes it technically difficult or impossible to recover all of the raw materials within the product, because they become impurities, some of the raw materials, when you want to extract some of the others. There is also loss of raw material due to corrosion, for example. That's why we mine zinc, to minimize corrosion in cars, in nails, which are all clad with zinc in order to reduce the corrosion. Copper then. Today, recycled copper has a share of about 17% of current use of copper within the EU. In the rare earth elements, which here we have a piece of rock from one of the best rare earth elements deposits in Europe in terms of important rare earth elements. The rare earth element here, which is the pinkish one, it's called eudolite. And when we have this projected transition to electric vehicles, there is a need for green energy and the global growing populations. This means that we need substantially more raw materials, both copper and battery metals and rare rare earth elements, graphite, nickel, cobalt, and lithium, and even iron, actually, and aluminum. So, in order to meet the demands and the challenges we have in order to secure sourcing of raw materials, as a part of this policy, the EU has developed something called critical and strategic raw materials. And the current list, there are 34 materials as of 2023. And the critical raw materials, they are both of high economic importance for the EU and have a higher risk of supply disruption, meaning we cannot be sure that we will always have access to them. Strategic raw materials are raw materials needed to achieve the EU strategic objectives. These include the green transition, digitalization, space technology, and defense industry. So therefore, copper, for example, is a strategic raw material. What is the global production? How much do we produce within the EU? And when we look at the pie chart on the right, we see that the lion's share of the critical raw materials are produced outside of the EU. Very little is produced within the EU. So even the things that are produced in the EU, it's only fluorite and hafnium that has some 49 to 32% that are produced within the EU. Otherwise, the most is actually imported. Then, if we have a look at what the raw materials, let's have a look at some specific raw materials. What you see here on the right is a piece of chalcopyrite. And that is one of the most important raw materials, minerals, that we extract from the earth to produce copper. So it's, as we said, one of the most important raw materials. And the production of within the EU is about 960,000 tons per year. But that is only 43% of the total need. And recycling was only 17% of the demand. And then some is exported also of the produced copper, so we are actually importing 48% of the consumption. We need more recycling, but available copper to recycle is not enough to meet increasing demand, because copper in use has long lifespan. There is loss due to corrosion, not possible to collect, and also sold outside of EU. Further is that a lot of the copper is actually used and not available for recycling. And we also need more copper than we are actually using today because of the increased challenges of electrification and the green transition. Then cobalt, which we see here on the right, is a cobaltite from a site in Sweden called Håkansboda. And it's needed in rechargeable batteries, superalloys, gas turbines, jet engines, space vehicles, power plants, magnets, pigments. And the EU production was about less than 1,600 tons per year, whereas we need more than 21,000 tons. So it's less than 10% was produced within the EU of the need that we have. And from primary mining, it's mostly byproduct of copper and nickel mining. And the recycling rate of cobalt in 2020 was 22%. And many of these raw materials, not far from all of them, but they are also essential trace elements for our body, like cobalt is for vitamin B12. Lithium, which has been heard quite a lot about. And here we can see that we have on the right spodumene and cassiterite, which are two lithium-bearing minerals. There is also a mineral called apatite here, which is actually a mineral that contains may contain rare earth elements also. It's mined either from hard rock or salt brines. Salt brines, that is, for example, from the big salt plains in Chile and Peru. It's used in, for example, batteries, ceramics, and glass. It's also pharmaceutical products and lubricating greases. Batteries consist of the main share of the lithium use in 2021. And there is no EU production from primary mining that is refined in the EU. There are though several advanced exploration strategic projects which aim to cover this gap. And the recycling is also negligible. And there are significant lithium resources within Europe. Graphite, which we see a piece of rock here containing graphite. And it's used in metallurgy, batteries, lubricant, pencils that we write with. For example, 99% of all graphite used within the EU is imported as of 2020. There are substantial processing plants within the EU, large-scale resources existing both in Sweden and Finland, among others, and there are advanced projects that aim at cover the gap of EU production. The recycling is low, is less. It was in 2016, 3% for end-of-life products. Then the rare earth elements, which this is the same rock here, which we see here, as we see on the picture, which today is an extremely important series of elements that are used in everything from cellular phones to cars to electric vehicles. But it's most important, one of those more important uses is in magnets, because they make the magnets more stronger, and thus you need much smaller magnets, leading to that you get more efficiency out of, for example, wind turbines, but also that the cars became a little bit lighter, so there is less energy necessary in order to drive them. Into this group, yttrium also belongs. EU import 100% of its use. There is currently no domestic mining. There are two advanced projects. One is the Norra Kärr, and they are in Sweden. The other is LKAB in northern Sweden. The LKAB has been appointed strategic project and aim to be in production in the near future with the full value chain. There are also substantial resources on Greenland. So the next step in the EU policy here and actual legislation in order to meet the demand for critical raw materials, which we see here on the right, we see some of the uses of the critical raw materials, but they have a much wider use than actually the picture on the right shows. So they're actually also used in a lot of industrial tools, industrial production, also, not to mention almost all electronics. So therefore, the Critical Raw Materials Act was adopted in 2024. And the aim of it was to get us better access to domestically sourced critical raw materials. And therefore, one of the parts of the Critical Raw Materials Act was strategic projects that will fast-track projects in the permitting. It also pushes of better data information containing critical raw materials. And what we see here behind me here actually is a result of these efforts that is will be improved upon. What we see is behind me is a map of the critical raw materials of Europe. Thanks to the Geological Service of Europe's project then Critical Raw Materials Act. It has some benchmarks that we strive for. That at least 10% of the EU's annual consumption is from extraction, from mining. At least 40% annual consumption is being processed within the EU. At least 25% of the EU's annual consumption is being recycled. And no more than 65% of EU annual consumption from a single third country. So the Critical Raw Materials Act, it doesn't mean exemption from any legislation. Conditions are set in the national regional legislations must be met. However, the process leading to decision of the project must be fast-tracked by the authorities. There are minimum times of 24 to 27 months for projects to be permitted. The process must also be facilitated by a single point of contact as appointed by the authorities. There is a single point that will guide and push through the permitting process towards a yes or a no. And it's currently being implemented in the EU since the Act came into force in 2024. So permitting then, in general, you need permits throughout the whole process from exploration until mining to restoration. Mining process starts with an exploration permit, or rather it starts actually with the data, which we see here to the right, where we have a collection of geological information, of drill cores, which contain information of important mineral deposits in Sweden. And there are other countries also that have drill core archives containing similar information that can be used by exploration and mining companies. The process for handling exploration permits, and which comes after the screening of then the company apply for a particular area for a exploration permit. During exploration, they develop a mineral resource so that they know if it's worthwhile to pursue or not. So they come to a stage when they see that this mineral deposit either has a value or not. If it has a value, they will go on. But it's only 1 out of 500,000 projects that comes to this stage. So therefore, important with short times of achieving a permit, because it takes a long time to explore also. So the exploration, as we said, it begins with desktop study, exploration permit, and it goes into field work. If successful, evaluation, application for mining license, else abandoned area. Exploration programs have a minimal environmental impact. Drilling has minimal impact compared to the already existing fractures of the uppermost 500 meters of the crust. Therefore, we don't expect that the drilling, or we know that the drilling will not cause mostly any harmful effects, and it will not really be seen once it's being passed down. Operating and closing a mine. Once the exploration has been advanced, the company then apply for exploration for a mining license when they see that it contains economically viable resources. And then the applicant must present plans, and it's usually done in the environmental impact assessment. And they will also contain the mining plans, restoration plans, so-called remediation. It's the environmental impact assessment contains an environmental aspect to show that the mine is economically sustainable and can operate accordingly to the environmental legislation. And the remediation plan contains an economic safety to ensure remediation if the company goes bankrupt. So this is important to understand, is that the company cannot start an operation without having a safety that under all circumstances, even if the company ceases to exist, there will be resources set aside for rehabilitation of the mining area. Further, there are also land use aspects, and where in the process the land use is solved and dealt with, it differs from jurisdiction to jurisdictions. There may also be a number of other permits depending upon which member state the project is within. With this, I would like to thank you. We have both a vocabulary here within and the quiz. Thank you very much.